Quadrilaterals. So today we learn what are quadrilaterals, what are the different type of quadrilaterals, and what are the properties associated to these type of quadrilaterals. So let's start exploring. Firstly, what are quadrilaterals? A closed figure formed by joining 4 points where no 3 points are collinear. So the condition is no 3 points should be collinear and there should be 4 points. So let's suppose we have these 4 points 1, 2, 3 and 4. We can see that all these 4 points are collinear and hence form a line. Let's take a look at another case. This is point 1, 2, 3 and 4. Here these 3 points are collinear and if we join all the points we'll get a triangle. And now if 3 points are not collinear then we'll get something like this, and if we join we'll get this kind of figure. This is called a quadrilateral. Here is an enhanced figure. Here ABCD is a quadrilateral because quad means 4 and it has 4 sides. Side 1 is AB, BC, CD and DA. All these are the 4 sides. So the first condition is that a quadrilateral should have 4 sides. The next one is it should have 4 angles. That is angle A, angle B, angle C and angle D. 4 angles. And the last one, a quadrilateral should have 2 diagonals. Here AC and BD are the 2 diagonals. So a quadrilateral must have 2 diagonals. A quadrilateral is formed by 4 points when no 3 points are collinear. Therefore, a quadrilateral must have 4 sides, 4 angles and 2 diagonals.
Television screen, an envelope or a canvas are all examples of quadrilateral. Quadrilateral is one word, but you can see that this part is colored red and this part is colored blue. Quadri basically means 4 and lateral means sides. If you observe, all these things have 4 sides. This is an example of a quadrilateral. To name the quadrilateral, we give names to these 4 points. We call them A, B, C and D. These things that we just named are called vertices, and a quadrilateral will always have 4 vertices. Each point is called a vertex, and as we've already seen, a quadrilateral has 4 sides, and the sides are called AB, BC, CD and DA. So remember, every quadrilateral has 4 sides and 4 vertices. There's another important property of quadrilaterals. Consider this table. The surface of this table is flat. It's a plane surface. If I draw a quadrilateral on a table, it will look something like this. If you look at the quadrilateral closely, you can see that all the vertices and sides of the quadrilateral lie on one plane. So a quadrilateral has 4 sides, 4 vertices and is a closed figure lying on one plane. Observe that a vertex is formed when 2 sides meet at a point. And what is formed between those sides is called an angle. This is an angle. A quadrilateral is also defined by its angles. It has 4 angles. Apart from the one we marked, this one and this one. These are the 4 angles formed in a quadrilateral. But how do we name the angles? How can we name this green angle? Well, we can call it angle A. We just named the angle based on the vertex at which it is formed. But a better way to name it is to call it angle DAB, or you can also call it angle BAD. In these 2 cases, we named it based on the sides. Similarly, this angle can be called angle ABC. This one can be called angle BCD and this one angle CDA. And here's the last basic concept you need to know. In this quadrilateral, vertices A and C are opposite to each other, and vertices B and D are opposite to each other. The lines joining the opposite vertices are called the diagonals of the quadrilateral. So these two lines are called the diagonals. In this figure, we can say that AC and BD are the diagonals. What are its practical applications? When you watch this video on a 17-inch laptop, what do you think is 17 inches? It's the length of the diagonal. Even when you watch your favorite TV series on a 51-inch TV, it's the diagonal that is 51 inches. So remember, a quadrilateral is a closed figure on one plane which has 4 sides, 4 vertices and 4 angles.
In this video, we're going to look at angles in a quadrilateral. The 4 angles in a quadrilateral, or a 4-sided shape, will always add together to give you 360 degrees. So if we've got a quadrilateral like this one with angles A, B, C and D, the 4 angles will add together to give you 360 degrees. Let's have a look at a typical question now. There's a typical question whenever you've been given 3 angles and you've got to work out the 4th one. So in this, we know that all 4 of these angles will add together to give you 360 degrees. So to work out the missing one, you would add together the 3 you've been given and take that answer away from 360 degrees. So we're going to add together the 120 plus 60 plus 70. And we'll add those together and that'll give you 0. 2 plus 6 is 8, plus 7 is 15, put the 5 down, carry the 1, and that's 2. So these 3 angles add together to give you 250 degrees. So the value for x must be what you would add to this to get 360 degrees, or you would take the 250 away from 360 degrees. And when you do that, you get 110 degrees. So this missing angle is 110 degrees, and that's it. So they're quite common questions where you've been given a quadrilateral, you've got 3 angles, and you need to work out the 4th one. You just add them together and take it away from 360. Now this question, we've been asked to explain why the sum of the 4 angles add together to give you 360 degrees, or why the sum of the interior angles of any quadrilateral is 360 degrees. So to do that, what I would recommend you do is you cut the quadrilateral into 2 triangles. So you just join up 2 opposite corners. And what we're going to do is we're going to look at the angles in each of those triangles. Now we know the angles in a triangle add together to give you 180 degrees. So those 3 angles in red will add together to give you 180 degrees. And the 3 angles I'm about to draw in blue will also add together to give you 180 degrees. And if you look, those angles cover all 4 angles of the quadrilateral. So that means that because they can be split into 2 triangles, and as the angles in each triangle are 180 degrees, the angles in the quadrilateral will add up together to give you 360 degrees, and that's it. Okay, so we've looked at how to answer a typical question whenever you've been given 3 angles, and we've looked at why the angles add up together to give you 360 degrees. Now what we're going to do is we're going to look at some special quadrilaterals and some special facts about their angles. So here we've got a parallelogram. So a parallelogram, the top is parallel to the bottom and the left is parallel to the right sides of the parallelogram. In terms of the angles, the opposite angles are equal. So if this angle here was, I don't know, 130 degrees, the opposite one would also be 130 degrees. Okay. If we want to find out the 2 little ones, well, if you add these together, you get 260 degrees. And if you take that away from 360, that leaves us with 100 degrees. And if we half it, because they're both the same, that gives us 50 degrees and 50 degrees. And do you notice that also the obtuse angle and the acute angle add together to give you 180 degrees? That will always be the case because the top is parallel to the bottom. These are what we call co-interior angles. So in a parallelogram, the opposite angles are equal, but also the obtuse angle and the acute angle will always add together to give you 180 degrees. Okay, let's look at a typical question now to do with parallelograms. So it says work out the values of x and y. So first of all, we know that the opposite ones are going to be equal. So if the value here is 60 degrees, y is also going to be equal to 60 degrees. Okay. Now there's 2 ways to get x. One, we can just know that, as I've just said, the acute angle and the obtuse angle will add together to give you 180 degrees. So we can just take the 60 away from 180 degrees. And that will give us 120 degrees. So that means that x is equal to 120 degrees. Also, we could have added together the 60 and the 60, which was 120, taken that away from 360, and then halved it, and that would have given us the angles for x as well. Okay, so that's a parallelogram. Next, a kite. On a kite, the angle, so if the kite's like this, the angle here on the left and the angle here on the right would be equal to each other. And also all four angles would add together to give you 360 degrees. So let's have a look at the question now. So the question says, shown as a kite, work out the size of x. So we've been given the angle on the right hand side to be 110 degrees. As the kite's got a line of symmetry, the angle on the left will also be 110 degrees. And now we just need to work out x. Now all four angles will add together to give you 360. So if we add together the 110, the 110 and the 80, that will give us 300 degrees. And so then that mean that x is going to be 60, because we're going to take the 300 away from 360, and that leaves us 60 degrees. So to recap, a kite, if you've got a kite like so, standing in this sort of normal position, the left and right hand angle will be equal to each other as it's got a line of symmetry. Next, a rhombus. Again, a rhombus, the opposite angles are equal to each other, and the acute angle and the obtuse angle will also add together to 180 degrees. Very similar, the same as a parallelogram. Okay. So here, it says work out the sizes of angles x and y. Well, again, the opposite ones are equal to each other. So if that's 105, y is going to be 105. And again, to get x, we could add together the 105, the 105, and take that away from 360 and half it, and that's what's left for x in the opposite one. Or you can just know that the obtuse angle, this is the obtuse one, and the acute angle will add together to give you 180 degrees. So if we just take 105 away from 180, that will leave us with 75 degrees. That means that x is equal to 75 degrees. Okay, and finally, here we've got a trapezium. Now on the trapezium, the top line is parallel to the bottom line. So that will mean that the angles here on the left and left, these two will add together to give you 180 degrees. And the angles on the right, these two angles will add together to give you 180 degrees because they're co-interior. Okay, so let's have a look at the typical question there. So it says, shown as a trapezium, work out the sizes of the angles x and y. So again, these two on the left hand side will add together because it's parallel, top and bottom. The angles here on the left will add together to give you 180, and the ones on the right will add together to give you 180. So x will equal 100 degrees. The reason being, well, 80 taken away from 180 is equal to 100 degrees. So that means that x is 100 degrees, 100 degrees. And y, if we take 130 away from 180, 180 minus 130, we will get 50 degrees. And that must mean that y is equal to 50 degrees. And if we just check our answer, 100 plus 50, 150, plus 130 will be 280, plus 80 equals 360. So all four angles add together to give you 360. That's it. So just to recap, the angles in a four-sided shape will always add together to give you 360 degrees. If you've been given a quadrilateral and you know three angles, you can add them up and take it away from 360 to find the missing one. The angles add up to 360 because you can split it into two triangles, and the angles in each triangle are 180 degrees. In a parallelogram, the opposite angles are equal to each other, and the obtuse and the acute angles will add together to give you 180 degrees. A kite, the angle on the left and the right will be equal to each other if it's upright, like so. A rhombus is the same as a parallelogram. And finally, a trapezium. If the parallel sides are the top and the bottom, then the angles on the left will be added together to give you 180 degrees, and the angles on the right will equal 180 degrees. That's it.
Welcome to mathsmaster.org. Let's learn about angles in a quadrilateral. Quadrilaterals are four-sided shapes made up from straight sides. And the angle rule that we're about to learn actually applies to all quadrilaterals. So whether it's a rectangle, a rhombus, a square, or even an irregular quadrilateral, whatever quadrilateral you can think of, this angle rule will apply to it. This angle rule is that angles inside a quadrilateral always add up to 360 degrees. We're talking about the interior angles here, the angles inside the quadrilateral, and the rule is that those four angles inside the quadrilateral will always add up to 360 degrees. Let me show you now why angles in a quadrilateral add up to 360 degrees. Let's see if we can understand where this comes from. What I've got here is a rhombus, and what you can do to actually any quadrilateral is you can add a line that links the opposite corners of the quadrilateral and split it into two triangles, as you can see here. So I've added a single line that links some opposite vertices of the quadrilateral, and that splits it into two triangles. Now we've already learnt the angle rule that angles in a triangle add up to 180 degrees. So in the green shaded triangle here, you can see that the angles must add up to 180 degrees because of that angle rule. And then in the other triangle, the angles in that one must add up to 180 degrees. But the quadrilateral is made up of both triangles. So we need all of the angles in both those triangles to make up the angles of the quadrilateral. So two lots of 180 degrees make up the 360 degrees which we have in this quadrilateral. Let's see how we can use this angle fact, angles in a quadrilateral add up to 360 degrees, to solve an angle problem. Here I've got an irregular quadrilateral, but this angle rule, as I've said before, works for whatever quadrilateral you can think of. Okay, so we have an irregular quadrilateral here which has angles, interior angles of 60 degrees, 95 degrees and 100 degrees, and it also has another angle x which we don't know the size of yet, and we're going to use the angle rule to calculate it. So angles in a quadrilateral add up to 360 degrees. So we can say that 60 add 95 add 100 add x is equal to 360 degrees. Or another way of thinking that would be to say, if we start with our 360 degrees, we take away 60, take away the 95, take away 100, what would be left with is x. So x, angle x, must be equal to 105 degrees. That was angles in a quadrilateral. If you want to see some more fantastic maths videos, please visit mathsmaster.org.